Alright guys, so now we're gonna get into the code. I have already gone ahead and created a folder called animation and a class called animation that, as you can see, is empty. Added the basic includes. Another set of things that I did on offline is I brought the position vector out of all my entities into the abstract class. Since all of them had anyways, and all of our entities, game entities, are going to have a position, it only makes sense to bring it here rather than redefining it every time. So go ahead and transfer it. Make sure you make it protected so it's accessible to the children classes. Another thing that I went ahead and did is I declare a GUBLEC texture on my game asset manager, and I loaded it much like we did in the past. And I created a method called getGubler so that we can get that image out of it. Right. So to get started, one of the things I like to give this one is my it's a reference to the source image. This is so that we can get information such as the width and the height. Now you can pass that information in, but I'd rather have the entire object rather than to have a be passing all the other extra pieces by themselves. The next thing is double, and it's the delay, and this is going to tell us how long it should stay on a given frame. We're going to declare something to keep track of the current frame. Something to keep track of when we should be updating next. And this is the time in which we should switch frames. And you'll see how we use it later on. So let me just go ahead and declare some of the other ones, like the end frame and the start frame. Whether the animation loops, so in other words, whether it goes back and forth when it reaches the end, or it just stays at the end. And now it comes to the actual rectangle, which is the rectangle that we're going to be looking through for a given frame. And of course, we want to keep track of what the frame width and the frame height is. Okay, so that should take care of most of our things. We'll add anything else that needs to be added later. But for now, let's go ahead and declare the constructor. Right, so let's just instantiate each one of them. Pretty usual, regular constructor implementation, nothing new here, so I'm going to try to go ahead and get this over with quickly. Right, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Seems like we got them all. Let's also go ahead and create the rectangle. And then just frame width and frame height. Right. So far so good. We created the rectangle that we're going to use for each frame. Now let's go ahead and create a helper method that is going to modify the X and the Y of the rectangle depending on what our current frame is. And then if the current frame is greater than the last frame, then we need to check if we're looping. So if we loop, then we just set it back to the beginning. If we don't loop, then we just leave it at the end. Now we're just gonna do some math, simple math, so that we can figure out if we're in the range. Actually, we don't even need to figure out if we're in the range anymore because we're getting the handle up there. Otherwise, one little trick that you can use is you can use modulus. If you were wrapping around, instead of having to do the ifs that we did at the top, you can use mod, and then just calculate your current frame on the X and on the Y for it. In here, we're just gonna do it this way. This is in case that we had more than one row. Whenever we reach the end of the row, it would come back down and drop one down, so it would do a nice little redirect. But in this case, again, we don't worry too much about it because it's just one row. Right. So the next thing we're gonna do is we're gonna get yet another helper, and we're gonna call this step animation. And what this is gonna do is gonna move our frame forward by 1, and we're just going to update the rectangle. Okay. So finally, let's define our update method. In this case, I'm not going to pass time, I'm just going to pass double time instead of passing the actual time object. So in case you want to reuse this code elsewhere, you may. It's not linked to the XNA with the exception of the textures. So what we're going to do is we're going to say if the next time to update, where did I put that one? Let's see. There we go, nothing there. Good. If the next update is less than our current time, because this is how much time has passed in the entire game. So if our update is less, we're going to step the animation by 1, and then we're going to calculate our next update time. So equals to time plus, and this is where the delay comes in. And then let's just get a getter so that we can get that rectangle that we're calculating. Okay. And this completes our animation class. Some basic information we're passing in, how much it's going to take, what the start is, what the end is, how wide each frame is, the image object itself, so you can calculate how big the image is. Every time we move forward, we calculate the new X and the new Y for a frame. Every update, once we're done with the time for showing a given frame, it's going to go to the next frame and it's going to try to display it and hold there for as long as whatever your delay is. And again, the delay is going to be in milliseconds, so I have to keep in mind. And that does it for this one.